one?
Yeah, that's fine. Okay, so this one is telling us that we have each driver. So you'll notice in the table, you have driver 1, and then we have 2 different recordings because first they had 2 different types of gas that they used. So what kind of samples are these, independent or dependent? Dependent, because it's one driver and 2 different samples. Okay, so part A is dependent. That means if it's dependent, you have matched pairs data. So matched pairs we set up a little bit differently. We do our L1 and our L2, but what else do we have to have? The L3. And how do you find L3? Okay, so go ahead and enter these. Do the 87 in your L1.
Will match pairs always be dependent?
Will it what?
Always be dependent.
Yes. And that's the only time you do matched pairs is if your data is dependent.
Are those the only ones that are dependent?
Mm-hmm.
Those are
Yep. Okay, so you do L1, L2, L3. Remember, if you go up onto the title, then you can do L1 minus L2 and hit enter, and it calculates them all for you. So part B, the null and the alternative. So for matched pairs, that's when you have dependent data. The null is always the same. You have to do the mean of the difference equals 0. That's like saying there is no difference between the two. Okay. The alternative we have to think about. I know a lot of you were a little confused on this one. We have to decide, that shouldn't be equal to, if it's less than or greater than 0. So this said you were trying to decide if the higher octane fuel resulted in better gas mileage. What you have recorded here is the number of miles they drove. So the better the mileage, the more miles you get, right? So the higher octane was the bottom one. So I want to see if that one is better. That means this number is larger. So when you subtract them, do you get a positive or a negative? A negative, because I want the bottom one to be more miles. So a smaller number minus a bigger number should be negative. So my alternative is less than 0. Okay, part C. Assuming this data is normal, test it at the 0.05 level. So we are just using our calculator. So we go to Stat, Tests, and then what do we need to do? Which one? T-test. So that is number 2. And like we talked about, if you go to do your tests and you don't have the correct options, you pick the wrong test. We want to run it off of data or stats? Data. The mean of the null was 0. Your list should be L3. You may need to change that. We are testing less than. And so you get T to be negative 1.1350. The P is 0.1414. We are testing at the 0.05 level. So you have to compare your P and your alpha. P is greater than alpha. You reject if P is less than alpha. So since P is greater than alpha, we fail to reject. Part D is the confidence interval. So go back to stat, calculate. Stat test. We're talking about the t's, but we need an interval, so that would be number 8. Okay, running off data, list is L3. Thank you. And we wanted a 98%, so confidence level 0.98. Calculate. And we get negative 17.49, comma 7.3053. Okay, interpret that, so that means we are 98% confident the difference in the means falls between these two numbers. I'm not going to write that sentence out, but okay. What else? Yeah. Okay. So problem 30. So we have determined, ACT determined that a score of 22 suggests the student is ready for college level math. So ACT recommends core curriculum. We have a random sample of 200 with a mean of 22.6 and standard deviation of 3.9. We want to know if this suggests students who completed the core curriculum are scoring higher than the 22. So part A, your null and alternative. Your null, are we talking about a mean or a proportion? A mean. So my mean equals what?
22.
The alternative, we want to know if they are scoring above, so the mean greater than 22. Part B, check your requirements. So I told you if it's a proportion, we have the p, that's when you need to do the n times p times 1 minus p, greater than 10. If we're just talking about the mean, we don't have a proportion to deal with, so we just check if our n is bigger than 30. So we did a sample of 200, which is definitely bigger than 30, so that requirement is met. And that's the only one I asked you to check there when we did this test. C, test it at the 0.05 level. So we are doing this on our calculator. So stat, test. Which test do I need? T-test. If you're talking about the mean, we always pick the t-test, number 2. This time I am basing it off of stats. Okay, the mean of the null was 22. X bar, the mean of our sample is 22.6. S sub x, standard deviation of the sample, 3.9. N, we had 200. We are checking if we are greater than. And so you get your t to be 2.1757. P is 0.0154. You always compare your probability with your alpha. We are checking at the 0.05. P is less than alpha, so what does that tell me? Reject the null. In other words, there is sufficient evidence that those students scored higher. So that was part D, your conclusion. There is sufficient evidence to conclude that those taking the core curriculum scored higher on the ACT. Okay. What else? Really anything from the entire study guide that I haven't talked about, I'm happy to go over now if we need to. Yes.
32C.
32C. Okay. I'm just going to run through A and B first to make sure everybody's okay with those. So this one we just had data from 2 different populations. Nothing about this indicates that these populations are related, that it was a before and after, so would they be independent or dependent? Independent. So that means this is not matched pairs. You do matched pairs if they are dependent. So null and alternative, we just want to know if these are, if the means are different. So the null would be the mean of the first equals the mean of the second. Alternative, if they're different, they're not equal. So now we are going to use our calculator. So if we go to test, we have 2 different samples. We're talking about the mean, so we need a 2-sample t-test, number 4. Okay, we are basing this off stats. X bar 1 is the mean of the first, that's 111. S sub x1, standard deviation of the first, was 8.6. N1, the number of the first, is 20. Second mean was 104. Standard deviation, 9.2. And 20. We're testing not equal. Do not change the pooled, should be set at no. Calculate. So we get our t to be the 2.4858. Your probability is 0.0175. Alpha was 0.05. So my p is less than alpha, which tells me reject. If p is less than alpha, we always reject. Okay. Yes.
Back on number 9, I just drew the thing with, like, I don't know what it's called, chart for the empirical rule. I didn't like write it out.
Oh, that's fine. Just make sure, like, you could answer those questions, you know, looking at the chart, like what percent falls within 1 standard deviation,
Okay.
what percent falls within 2, which is actually given on your formula sheet as well. What else?
So for 1 through 4, when you're like telling the difference between the 2 quantitative and qualitative, are you going to give us examples and then we have to tell which one it is? Or
Yeah, probably. So,
we have to choose from like the 2, right? Or
yeah, so I might ask you, like, Unit 1 I did a lot of on your study guide, just asking you for definition. But on the final, those are probably going to be your multiple choice type questions. So I might say, you know, height of a person. Is that qualitative or quantitative? So height would be quantitative. Is that discrete or continuous? Continuous. I might say, like I fill in the blank. Blank is the group of all subjects being studied. So if it's everybody, that is a population. If I said it is a subset of the group, that would be a sample. If I said, if I am collecting like a numerical value describing a sample would be a statistic. A numerical value describing a population would be a parameter. You know, I might ask you the multiple choice questions, you know, look at a graph and tell me, is this symmetric, is it skewed left, is it skewed right, those types of things. What else was on our definitions? We talked about empirical rule. Unit 2, I asked you some questions. Blank is best used to describe the middle when your data is symmetric. So if it's nice symmetric, what describes the middle the best? The mean. The mean is great, but if I throw in a really big value, it changes our mean a lot. So if you have outliers, what would be the best? The median. Now I might ask you something about, I also put z-score in your study guide. So if I'm measuring the number of standard deviations away from the middle, that's talking about a z-score. So those definition type questions are probably what your multiple choice will be on your study guide, or on the final. What else do we want to talk about? Anything, I mean, it can be a specific question on here, or you can ask for additional practice with something on here. You guys remember to find correlation coefficients, what do you have to turn on your calculator first? Go make sure your diagnostics are on, so then when you run your linear regression, it'll give you the R. Probability questions, are we okay with those? Do we need some practice ones? Let me just make up a couple probability, because I know you were a little less confident with those. So I'll put a few problems up here and give you guys a minute or two to try them. Let's see. Alright, here's your first question. 4 probability type questions on here. Here's one more. Give you just another minute and I'll talk. Let's kind of talk about some of these and see. So this is all from our probability units. So the first two, they're not necessarily hard as long as you know what those things mean, right? If you know what mutually exclusive and independent are, it's not a big deal. So if A and B are mutually exclusive, what does that mean? They're disjoint. They can't both happen at once. So if they're mutually exclusive, what's the probability of A and B happening? If they can't both happen, what's the probability that they both happen? 0. It's impossible. So you have on your formula sheet a formula for disjoint and then not. Even if you pick the wrong one, you can get it. So if you know they're disjoint, it's just probability of A plus probability of B. If you didn't, you have to subtract off the probability of A and B. Well, the probability of A is 0.8, probability of B is 0.6. I made up a bad question, didn't I? I just made up something. Can I change this so it works? Let's say 0.3 there. I didn't check that any of my answers actually gave you a possible answer.
I'm confused why you're using that formula.
Why I put the minus there, or
Yeah.
just to show you that even if you did write down that formula, since they're mutually exclusive, I know that that's a 0. So
Okay.
that's why you could have left that off. And then you get 0.9. Okay. Second one, if they are independent, what does it mean if they are independent?
They don't rely on each other.
Yeah, one doesn't change the other. And don't you have, I don't have a formula sheet in front of me, but don't you have a general, or you have a general multiplication rule and then you have the multiplication rule for independent events. So all we have to do is multiply these. It's just probability of A times probability of B. So 0.8 times 0.6 gives you 0.48. Alright, so far so good? Now let's get into the more complicated one. So the probability of being in band was 0.1. Probability of being in choir was 0.4. The probability of being in both, B and C, is 0.06. So I strongly recommend making that list and writing out what you have. I want the probability of B or C. So looking at your formula sheet, what involves all of those things? Yeah, so we have the probability of B or C equals probability B plus probability C minus probability of B and C. I think it uses E and F on your formula sheet, but same thing. So then we just fill in probability B plus 0.4 minus 0.06, and we get 0.44. Is that one okay? Alright, the next one, we had one on our study guide like this. You were selecting things, pulling things out of a bag. So here we have a bag of M&Ms. How many total M&Ms are there? 30. Oh, wow, I even picked numbers that add up nice. Okay, so if I want the probability of 3 red, the probability of the first one being red would be the probability of the second one being red, the probability of the third one. Okay, so then, I don't have a calculator in front of me, but what does that come out to be? 0.0296? Is that okay? Alright, let's look at this table. I put the conditionals on here because that's what I felt like you guys really struggled with the most when we looked on those. So, when I give you something like this, no given group B, what goes on the bottom? Group B. So if we add that up, group B is 13. So I am only looking at that part. I already know we're in group B. So then my numerator is from those which ones said no. So we get 7 out of 13 or 0.5385. Second one, yes given not in group C. So you have to add up groups A, B, and D, and you get 29. Out of those, so everybody but group C, how many said yes? So 18 out of 29, or 0.6207. Last one, group D given yes. So my denominator is just the ones that said yes, so that would be 23. Out of those, which ones were in group D? So 8 out of 23, or 0.3478. Huh?
Like the ones that aren't given, like the or and the ands.
Yeah, so if I said, what is the probability of group A or no? So this time my denominator will be everything, right? So if you add them all up, what do we get? 44. So we have to start with the ones that are in group A. So group A is 7. So you have 7 out of 44. Plus the ones that said no. So if you add up all your no's, we have 21 out of 44. But there is a problem because I added up all of my group A and I added up all of my no. What if I double counted? Those 3, the group A's that said no. So if we subtract those off. And we should get 0.5682. If I said the probability of yes and group C. What's my denominator? My denominator is my 44. Everybody, my numerator is just those that said yes and were in group C, so that would be 5. So it would be 5 out of 40. Does that make sense? Any other probability questions? You should be able to make like your frequency and relative frequency table, which I don't think that was a big deal for anybody. Right, we did that on problem 7, so you guys could do that. Problem 13, we did the linear correlation coefficient, so that was on the calculator. You should be able to do that. The line of best fit, that's given on the calculator. What about like question number 11? That was pretty big for our first unit. We found all of that stuff. Are there any questions about how to find that or need any practice with it? It's pretty much all either from the calculator or the formula sheet. So do I need to go over any of that one? Okay, let's do a binomial question then. So let's say So let's say the probability, we have a certain tire company. Now, probability of them making a defective tire is 0.15. Let's say a sample of 15 tires is inspected. So first of all, why is this a binomial?
Because the tires are either good or bad.
We only have two possible outcomes. Either it's defective or it's not. It's a yes, no. So that makes it binomial. So if I said I want the probability that less than 2 have defects. So that means I could have 0 or 1 tire defective, right? If I said strictly less than 2, it doesn't include the 2. What is my n on this problem? How big is my sample? Okay, so my n is 15. What is my p? 0.15, probability of being defective. Okay, let's see if we can use our table, because that makes it a lot easier. The one on our study guide we couldn't, but 15 is on here, and is 0.15 on here? Yes, so we can. So for the first question, the probability that less than 2, so that means you could have 0 or you could have 1. So if we'll add those together. So go to your n equals 15, probability is 0.15. So at 0 you get 0.0874. 1 is 0.2312. So we should get, so there is a 0.3186. So 31.86% chance that less than 2 of them will be defective.
How do you know when you will add the 2?
If I said no more than 2, then that would have included the 2. What if I asked you for the mean and standard deviation? So it's binomial. How do you find your mean? N times p. So 15 times 0.15 is 2.25. Your standard deviation was the square root of n, so 15 times p, 0.15, times 1 minus p, so 0.85. I get 1.3829. If I said find the probability that more than 13 have defects, what would you do? If it's more than 13, what could it be? 14 or 15. So you would just add up those probabilities from your table. Okay, are we all right with that? Looking at your study guide here, like number 17, the probability distribution. So just be prepared to make that table and find the mean or standard deviation if you needed to. The normal table, so like question 24 just asked you to read things from the table. Do we need one where we have to look up things from the normal table, like 25, or are you guys okay with that? You're okay with it? Okay. About like 26 when we have the proportion and you have to convert it to a z. Are those still okay? We have like 5 minutes. Is there anything else you need me to go over? Other than how to calculate your grade. Hit that real quick too. Yeah.
What t-test did you use for 29?
29. That one was just the rate. That one was a P, because 52%. So you did the one proportion Z test for that.
Thank you.
You're welcome. Anything else? Okay, so question about your grades. Let's say that you currently have a 91% in the class and you want to keep a 90. So this is what you have. This is your goal. Okay. This is my semester grade that I'm using right here. So your semester grades show up in CIS. The final is 20%. So when I find your grade, I'm going to do 0.2 times your score on your final plus 0.8 of your current semester grade. So your current grade is 80% to equal the final grade. So if you currently had a 91, you would do 0.8 times 0.91, and you wanted a 90 because you wanted to keep your A, then I would end up solving this equation. So I would have 0.2x plus divide by my 0.2, and that shows me I would need an 86% on my final to keep that score. Okay, so you want to use this, plug in what you currently have and what you want, and then you can find what you have.